Alright, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today, me and my group will be present about defect analysis of sand casting, CO2 casting, and welding process. Okay, so this is our group member. First of all, Muhammad Al-Fazikri bin Shuairi. Next, we have Muhammad Arif bin Roshdad. And the third one, we have Nazim Najmi. And the fourth one, myself, Muhammad Hazimi Tisham, Muhammad Rafi'i. Alright, so let's move to the objective of this presentation. So, first of all, we want to identify defects and causes in the sand casting, CO2 casting, and welding products. Next, to identify defects found in the manufactured products. The third one, to explain causes of defects. Fourth one, to discuss the inspection method. And lastly, to propose improvement for better quality product. Alright, so let's move on to the introduction to sand casting. Okay, so first of all, sand casting is one of the oldest and most widely used metal casting process. Molten metal is poured into sand mold cavity, and after the solidification, the sand mold is broken to remove the sand casting. So sand casting is suitable. It's very suitable for producing complex shape at a relatively low cost. So which means manufacturing have used this method, sand casting product, to produce the complex shapes such as engine block and so on, so that it can reduce the cost itself. Alright, so this is the introduction to CO2 casting. So first of all, CO2 casting uses silica sand mixed with sodium silicate as binder, and CO2 gas pass through the mold to hardening it, and then it produces a stronger and more rigid mold than conventional sand casting. Alright, so this is the comparison between sand casting and CO2 casting. So we have, first of all, sand casting just use clay plus water binder, while CO2 casting uses sodium silicate plus CO2 gas instead. Next, in sand casting is relatively low cost than CO2 casting. It is also longer mold preparation, while CO2 casting is faster mold hardening. Next, sand casting product have a rougher surface, while CO2 casting has a better surface finish. Next, sand casting has lower accuracy, while CO2 casting is higher accuracy. And last but not least, sand casting has higher probability of defects, and also CO2 casting has fewer casting defects. Right, so let's move on to the introduction of SMAW, which is shielded metal arc welding. So, shielded metal arc welding is also known as stick welding. It's a manual welding process that uses a consumable coated electrode to produce an electric arc. The heat generated melts both the base metal and the electrode, forming a stronger welded joint. While this is the introduction to GMAW, which is gas metal arc welding. So gas metal arc welding, commonly known as MIG welding, uses a continuously fed wire electrode and shielding gas to protect the molten weld pool from atmospheric contamination. So overall, basically this is the manufacturing process of sand casting and welding. First of all, for sand casting, we move to the pattern making, sand mold, preparation, pouring molten metal, cooling, and cleaning. So this is the picture that I'm gonna take by our group, shown the process of sand casting by itself. Next, we have welding, which is first of all, we need to prepare the surface. Next, welding process is continued. Next, cooling, and then inspection. So this is one of our group member that that been through the MIG welding. So next, for defect casting, and so on. We move to the next group of member. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nazim Najmi bin Abdul Razif, and I will be continuing the presentation slide for this part. And moving on to the defects in casting, uh, the first one is the porosity. This can happen when the trapped air gets caught as the metal solidifies before it can escape. Uh, to prevent this from happening, we can do proper mold venting by drying the sand mold properly before pouring. Next is the shrinkage. The causes of shrinkage is insufficient filling of molten metal during solidification. When metal shrink faster than it replenishes, especially in thick section. As the solution for shrinkage, uh, a proper riser and feeder placement can prevent this from happening to feed the molten metal into section as it solidifies. The, the next one is cracks. It is caused by a restriction contraction during cooling process combined with thermal stress. As for the solution, we can improve mold collapsibility and control cooling rate to lower thermal stress. And the last one is sand inclusion. Sand inclusion caused by poor ramp mold or more mold erosion during pouring process. To prevent this from happening, a proper mold ramming and controlled mold pouring rate can prevent sand inclusion. Uh, in welding process, the most common the most common defects that we can identify is porosity. Porosity causes by trapped base metal and incorrect shielding gas flow and an excessive arc length. Uh, to prevent this from happening, we can clean the base metal before welding, and we can adjust the proper gas flow rate and arc length. Next is the incomplete fusion. Incomplete fusion can happen when the heat input is too low, the angle alignment is wrong, and travel speed is too much. As for the solution, we can increase the heat input, we can use the proper angle for welding, and we can also control the travel speed. Lastly is the undercut. Undercut causes by too much current flow and travel speed. To fix this, we can adjust the current and travel speed, and we can also use the proper welding technique. Every manufacturing activities consists of people and tools and machine. First, we will go through to the people. As in the people section, there consists of four roles during manufacturing process. First is the mold maker. They are the one that will prepare the mold, and then the pourer, uh, the one that will handle the molten metal, the welder, the one who carry out the welding process, and lastly the instructor, the one that guided and supervised the entire team during the manufacturing session. On to tools and machine, there are ramming tools that is used to compact the sand mold. Next is the welding electrode, the one the welder use to carry out the weld, the sprue cutter to shape the pouring channel, and lastly the SMAL or MIG set, the welding set to perform the actual welding process. In manufacturing activity also requires data uh, to play an important roles in guiding the process decision. And one of the main highlights in data is the melting point of alloy to determine the correct pouring temperature and monitor the pouring temperature itself to avoid any defects like porosity or shrinkage. Next is the welding current. This is to ensure the proper fusion and avoid issues like undercut, along with cooling time charts to control the rate of solidification and reduce the risk of cracking.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Arif bin Rushdan. Moving on to our project structure, let's look at the engineering activity perspective and our team roles. First, first of all, we have Arif as the manufacturing lead. He manage the welding machine parameters, handle the casting mold setups, and monitor strict workshop safety and PPE compliance. Next, Sham acts as our quality inspector, executing detailed visual inspections using welding gauge and conducting step-by-step liquid penetrance testing. Ajimwan, our data and process analyst, took charge of recording the time to fabricate for both sand and CO2 molds while collecting and documenting all defect data and mechanisms. Finally, Alpha serves as the sustainability coordinator, evaluating material waste and cycle efficiency, and mapping all our technical findings directly to SDG 9 and SDG 12 targets. To work smoothly, our team held discussions right after the workshop to review defects and agree on their root causes. At the same time, the quality inspector and sustainability coordinator cross-check all data against industry standards to avoid any mistakes. In the next slide, I will explain the inspection and evaluation methods we implemented to ensure quality control. We focus on two main non-disruptive testing approach. The first method is visual inspection. For each application, we use a welding gauge and a magnifying glass to check for immediate surface defects, such as undercuts, surface porosity, and dimensional accuracy. In industrial practice, visual inspection is done as the first mandatory quality check across industries based on the AWS D1.1 standard before proceeding with any other test. The second method is liquid penetrant testing, or we call it LPT. For the application, we apply a red dye penetrant on the weld, clean the excess, and use a white developer to pull out and clearly expose any hidden surface cracks. In industrial practice, LPT is widely used in the oil and gas industries following ASME Section 5 to check the safety and tightness of pressure vessels and pipes. Based on our findings and defect observed, we have formulated three proposed improvements to optimize future production. First, digital process control through equipment upgrades. We propose using digital inverter welding machines with synergistic control to automatically stabilize voltage and current. This directly prevents human errors that typically cause undercuts. Second, preheating and material handling. Preheating the casting molds and welding electrodes before production helps remove moisture. This critical step eliminates defects like porosity and hydrogen-induced cracking. Third, advanced mold coating. As a common industrial practice, applying a zircon-based alcohol mold wash on the sun mold surface and burning it off before pouring metal creates a much smoother finish. This prevents the sand from washing into the liquid metal, ensuring high structural integrity. That's all from me. I will pass the next slide to the next member.
Okay, here is the synergy of SDG 9 and SDG 12. For SDG 9, industry innovation and infrastructure, as known as sustainable industry. It can cause the industrial retrofitting, which is re-engineering manufacturing assets to optimize resource efficiency and cut emission. It also can have a clean innovation, which is designing circular process technology that naturally exclude toxic chemical waste loop. For SDG 12, which is the responsible consumption and production, also known as resource stewardship. This SDG 12 can also be explained by closed loop system, which is transforming traditional like linear take make dispose pathways into recursive biological loops, and zero waste initiatives, which is reducing industrial chemical discharge, consumer electronic and food waste by 50% by 2030. SDG9 provides the physical infrastructure and technical innovation necessary to convert raw waste into fuel. In return, SDG 12 establishes the supply chain targets that incentivize manufacturers to adopt sustainable process, driving a net zero circular economy. Now, for the last page is conclusion. As a conclusion, defects in sand casting, CO2 casting, and welding all stem from a few shared culprits, which is poor temperature control, trapped gases, and stresses during cooling. While sand casting is plagued by moisture-driven blowholes and shrinkage, CO2 casting suffers from overly rigid molds that cause cracks, hot tears, and surface roughness. Welding faces similar issues, where rapid cooling and atmospheric contamination lead to cracking, porosity, and poor joint fusion. Across all three methods, the best fixes remain the same: precise temperature management, proper mold or joint design, and keeping material clean and dry. So that's all from our group. Thank you.